students, welcome to our source classes, and this video is of Delhi School of Economics 2020. So let's have a look what we have in store over here. So the first thing is given is this. Okay, it's quite an unusual thing. This is called a negation sign. Okay, negation sign has also a different kind of formation. So let me just tell you, and also after this the relation based sign. So there are a lot of signs are being used over here. Okay, negation can be used in this way or in used this way. So this in the proportional logic, and if I say this, so that means the statement this is true if and only if A is false. And for example, if it is like this, so then A. So double negation. So x not equal to y can also be written as x negation, negate x equal to y. Okay, so in this way, and mostly it is used as basic logic symbols. So let me tell you one more interesting, one or two interesting logic symbols which will be useful. So this is a logic symbol that means domain of discourse. Okay, so domain of discourse with respect to real number structure, it is being used. And another one which you may not have seen is this is called essential quantification. This is uniqueness quantification. This means definition, which is same as this or this. Another one, turnstile, is this thing. So that means proportional logic or first order logic, and obviously you can guess it, this will be proportional logic or first order logic as well. But this means, for example, if they write, so that means x proves y. Okay, but if this means x models y. Okay, so now let's do it directly. So the negation is of a statement. Consider a set of x, a binary relation on x relation. This thing actually is called irreflexive if negation of x irreflexive y for every x belongs to x. So this is actually x belongs to x. Okay, now if this is asymmetric and negatively transitive, then what is this meaning of this sign? Okay, so this is asymmetric and negatively transitive. So we need to check if it is irreflexive and transitive. So the binary relation x is a subset of x, so like x of x. So that is, in this case we can say x of x, that is to say is the element, there is an element of y which belongs to this, and negation xy is same as x and y does not belong to this. So first let's prove that this is irreflexive. Okay, so suppose that towards the contradiction it is not, and then there exists x which is belong to x such that x is of x. So by then the asymmetry, so this of x, so x irreflexive, so that means negation x to x. So clearly is a contradiction since both cannot be simultaneously true. So this is irreflexive. Now let's prove it is transitive. So any x, y, z. Transitive part is easy. So So by asymmetry we know this, and negation. So by negative transitivity requires that either x to z or z to y. So this must be true that x to z, which proves the relationship is transitive. So option number C is correct. Next question is a similar type again. A negation sign is given in the statement. Consider a set of x of a binary relationship, and for all x and y belongs to x and y this thing, and again asymmetric relationship and negative transitivity property, then which of them are true? So let's prove that is a total relation. So let's consider this belongs to x. To prove that it is total, so we need to show that the negation x transitive to y implies y to x. Okay, so we need to check that x belongs to x, and this by the definition and the fact that this is irreflexive is already shown above. Okay, so I'm not showing that. So this is irreflexive, so we can restrict attention to case where x not equal to y or negation x equal to y. Okay, in this case suppose that negation, so it follows from the definition that this gives, so by asymmetry of, so asymmetry of this sign, we then have the negation this, and by definition this is given as, this gives this, so the relationship is a total relationship.